This is an interesting question about support vector regression. So this is a question asked by one of our students. So let's take a very simple form of support vector regression, which is linear support vector regression, right? Wherein you just have a non-kernelized linear model here, right? So you have a data set of xi, yi, I going from 1 to n, and we have explained what a SVR formulation is in detail in the content video itself. So the question here is as follows. This is our optimization problem, right? This is my optimization problem that I'm trying to solve. So the question here is interesting. The question here is, for all data points I, we need these constraints to be satisfied. The question that the student has is, how can both these constraints be satisfied, right? So if you write this as yi hat, because yi hat is a predicted output for point xi, right? These two constraints can be written, or these three constraints can be written as simply yi minus yi hat less than equal to epsilon. Similarly, yi hat minus yi is less than equal to epsilon, and epsilon is greater than equal to 0. So the question here is, how can these three constraints be always true? And this is a very common confusion that many students have with SVR, with support vector regression constraints. So let me try to explain this with you with some diagrams, right? So these are the constraints. We have to show that these constraints, given an epsilon tube, right, that we want to fit around the function, we can accommodate errors of at most epsilon here on every point. Of course, epsilon being a positive value here. Okay, so let's draw it actually, that's better. So imagine this is my x-axis, this is my y-axis. Just for simplicity, I'm drawing a 2-diagram example, right? Suppose this is my hyperplane, right? This is my hyperplane, okay? And let's assume this is the actual hyperplane, right? This is the true hyperplane. And my epsilon tube looks like this, right? My epsilon tube is basically, right, a tube which is of maximum. So this gap is epsilon. This gap is epsilon. This gap is epsilon here. So this is called the epsilon tube that we have discussed when we learnt about support vector regression, right? Now what we are saying here is, given any yi, we want the yi hat, which is the model predicted value. And what is yi hat? Yi hat is nothing but W transpose xi plus b. So we want yi hat to be at most. So what does this constraints mean? These constraints are basically saying that the difference between yi and yi hat has to be less than equal to epsilon, whether yi is greater than yi hat or otherwise, right? So let's write it down. Let's write down the two cases here. So imagine this is my xi. Let's actually take an example so that it's easier. Suppose this is my xi, and let's assume this is my yi. This is the actual class label, actual regression value, not the class label here. Let's assume my yi hat is here. Suppose my predicted yi hat is here. Okay, it has to be right above this. Okay, so this is my gap, right, between yi and yi hat. So let's write two cases. Case 1. Case 1 is yi greater than yi hat. Okay, or the other way around, right? Let's write this example here. Okay, I think the diagram could be slightly confusing, so let me redraw it just for clarity. Okay, so this is my epsilon. This is my line here. This is my line here. My green point is here. This is my yi. Okay, this is my yi hat. I'll write it down here. This is my yi hat, right? And this is my yi, right? Here, what is case 1? Yi hat is greater than yi. What happens in this case? If yi is exactly equal to yi hat, perfect, we have no error. Then life is cool, right? What happens in this case? What happens to, see, look at both of our constraints, yi minus yi hat and yi hat minus yi, right? So let's write down yi minus yi hat. What happens to this? Okay, look at this. Yi is less than yi hat. Okay, if let's say yi is 2, yi hat is 3. Only then this whole value will be negative. This whole number is going to be negative. Okay, and note, this is very important. This is the important part here. Epsilon is always greater than 0. Because this is a negative number, because yi is less than yi hat, this is always going to be less than equal to, what does negative mean? Negative means that it's less than equal to 0. Okay, and we know that epsilon is always greater than 0. So by default, by default, if this is the setup that we have, where yi hat is greater than yi, you will get yi minus yi hat to be less than equal to epsilon, obviously, because this is a negative number. Now let's look at the second constraint. Okay, so this is constraint 1. Sorry, this is constraint 1. What is second constraint? Second constraint is yi hat minus yi should be less than equal to epsilon. Right? Yi hat minus yi should be less than equal to epsilon. This is my second constraint. Now, the very fact that yi hat is greater than yi, right? Yi hat is greater than yi, right? That's our case. We'll also look at the opposite case where yi is greater than yi hat. In this situation, as long as your yi hat lies within the epsilon gap, right? This is the epsilon gap, right? This is the epsilon tube, which means this gap is at most epsilon, right? As long as your yi hat that you've predicted is within epsilon distance, you're doing a good job. So in this situation, this will be satisfied automatically because this gap, okay, let me draw it here, because this whole gap is epsilon. This whole gap there is epsilon, but our point is here. This gap is less than epsilon. Very well satisfied. So there is no conflict here, as some students might imagine, right? Let's do the other case. Okay, this is case 1, right? I'll just erase this and draw the case 2. Okay, let's draw case 2. Okay, again, we'll turn up in a very similar situation. Okay, what is case 2 here? Okay, let's write down case 2. Okay, case 2 is where yi is greater than yi hat. What happens there? There, your yi hat is here, below the line, right? In this case, your yi hat is here. Then let's write the two constraints. What is the first constraint? Yi minus yi hat is less than epsilon. Yi minus yi hat is less than epsilon. Obviously, because yi is greater than yi hat, this value is going to be positive. Since we know that yi hat is within the epsilon tube, right? This constraint is going to be satisfied if yi hat is like this. Case 1, case 2. Oh, sorry, this is constraint 1, sorry. What is constraint 2? Constraint 2 is yi hat minus yi is less than equal to epsilon. Now here this whole thing is negative because yi hat is less than yi, right? And we know that epsilon is greater than equal to 0. We know that anyway, right? So obviously this constraint is satisfied because these are negative values. Because these are negative values and epsilon is a positive value. Positive values are always greater than equal to negative values. So this is automatically satisfied. So the whole thing, I completely understand this confusion. This constraints look like a minus b less than equal to something epsilon and b minus a less than equal to epsilon. But this is something that we have to keep in mind. There is a third constraint which is epsilon greater than equal to 0. And as long as your yi hat, either your yi hat could be above or below the yi, right? As long as it is in the epsilon tube around it, the constraint should work gracefully. I hope this confusion is clarified now. It's a very valid confusion because I remember going through the same thing when I was learning in my graduate school.